This is my pre-algebra course. Today we're going to learn how to solve inequalities, and we're also going to learn how to solve equations with decimals. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. So we're going to start with equations with decimals. The reason that we're learning equations with decimals is to show you that solving equations with decimals is really the same thing as solving equations without decimals. It's the same procedure. I also want you to understand before we start solving these problems is that you may use a calculator, because the purpose of this course, as I've mentioned before, is not to slow you down with a lot of difficult arithmetic calculations. The purpose of this course is to learn the algebra. Also, you may get some answers that have many numbers to the right of the decimal, and in that case you can just round off to the nearest thousandth. So let's get started. Alright, we're going to start by adding 2.3x and 5x to get 7.3x. Now we're ready to perform an operation on both sides of the equation, which means we have to rewrite the equation to preserve the result of our first step. And we're going to subtract 7.3x from both sides. And this is where you can use your calculator. Now we can do that calculation. We learned how to do that calculation in the last class, or the previous course. But the purpose of this course is not to learn arithmetic, it's to learn algebra. So I'm going to punch in 9.41 on my calculator, and I'm going to say plus 7.3. And I get 16.71. And I'm just going to add the negative after. So I prefer not to use negatives in my calculator. I just add those two numbers up, and then I put the negative afterwards. That seems the easiest way to me. But there's a lot of students that they just have to use the negative in their calculator. So if you have an iPhone, you're going to put 9.41. Then there's a button that says plus/minus, and you're going to push that button, and that's going to make the 9.41 negative. And then you're going to push minus 7.3, and that'll give you negative 16.71. Now, if you're using a different phone, you might have to put the negative sign first, then the 9.41. So it just depends on what type of phone you're using. And if you're using an iPhone that with an app that it doesn't come with the phone, then again, it might be different. So we're about to perform an operation on both sides of the equation here. So we're going to rewrite. And divide both sides by negative 16.71. And we're definitely going to need the calculator for this one. 4.6 divided by 16.71. And we got a number with a lot of digits. So we're going to have to round off. So I'm going to write squiggly lines for rounding off. And we got negative 0.275284, and it just keeps going on and on and on and on. So we're not going to write all of the numbers. So now let's review rounding off. It says up here, round to the nearest thousandth. So the thousandth place, let's find that place. That is here. And then we're going to look to the green number, one number over to the right, to figure out if we round up or down. So the green number is less than 5, which means we round down. So we keep the blue number the way it is, and the green number and all the numbers to the right of the green number, they become 0. And remember, when you have ending zeros to the right of the decimal, you can just get rid of those. So our final answer is negative 0.275. All right, so let's try number 2. Put a divider there. So I'm going to use my calculator to combine those numbers on the left side. of the equation, 7.6. And again, I prefer just to add the negative afterwards. I'm not going to plug in negatives to my calculator. We get negative 13.4. And now we're going to perform an operation on both sides of the equation. So we have to rewrite that equation. Subtract 1 from both sides. And we're about to perform another operation on the equation. So we have to rewrite again. And we're going to multiply by 2.6. And you have to put both numbers in parentheses on the left side, or else it'll look like subtraction. And this is a good calculator operation here. 2.6 times 14.4 is 37.44. And I'm just going to add the negative afterwards. And that's an exact answer, so we don't have to round off. All right. At this point, you can probably see what's going on here. It's really just the same situation that we had before. So why don't you go ahead and try number 3, and when you come back, we'll do it together. All right, we're back. So there's nothing really that we can do on the left side of the equation. So we'll just rewrite that. But on the right side of the equation, we can go ahead and subtract these. 4.1 minus 10, that's going to be negative 5.9. Now again, you can do that on a calculator if you want to, but after a while, after a lot of experience working with decimals, you're going to be able to do that in your head. So that would be negative 5.9. And now we're going to add something to both sides of the equation, so that means we have to rewrite. Again, whenever you perform an operation on both sides of the equation, you got to rewrite the equation. So we're going to add 2.7z to both sides of the equation. All right. So these 2.7z's cancel out. That's why we did that. And negative 5.9z plus 2.7z, that would be, I think, negative 3.2z. All right. So some of these calculations you can attempt in your head if you want to, but you should probably go ahead and check those on the calculator. So 4.1 minus 10, I'm just going to check to make sure I did that correctly. And 5.9 minus 2.7 is 3.2, and then add your negative. So now we're going to divide both sides, because when a number is right next to a letter, that means multiplication. So we have to do the opposite of multiplication to get rid of that negative 3.2, so we can isolate z. So we have to rewrite. So we're going to divide by negative 3.2. So 3.681 divided by 3.2 is equal to a number with a lot of digits to the right of the decimal. So we're going to have to round off because we can't write all those numbers. And we get negative 1.15, and that's it. You can just add a 0 there if you want, but rounding off to the nearest thousandths would produce that answer. All right, so if you got negative 1.15, good job. Remember, you have to round off to the nearest thousandths place. Now, if you forgot how to round off, you can watch my class in the previous course on rounding to get a feel for that. I'll go over the principles of rounding in the next problem if we need to round, just so you maybe don't have to go to the next class. But if you completely forgot how to do it, you should probably go to that class and just review that. All right, so now why don't you try number 4, and when you come back, we'll do it together. All right, we're back. So I simplified the right side of the equation. And I'm just rewriting because we're about to perform an operation on both sides of the equation. And I'm going to need to move this over. So now I'm going to add 2.7 to both sides of the equation. And because we have a plus and a minus, it's probably best to put the fraction in parentheses. And again, you can do 5.1 minus 2.7 with a calculator, or you can put negative 5.1 plus 2.7, and it just, however you want to do it. Just know that the negative defeats because the negative number is bigger, technically smaller, but the magnitude is bigger. So we're about to perform an operation on both sides of the equation. So we need to rewrite. And this is x divided by negative 0.09. So in order to get rid of that negative 0.09, we have to do the opposite of division, which is multiplication. And we show multiplication with parentheses in algebra. So then our answer is going to be whatever 2.4 times 0.09 is. So I'm going to use my calculator for that. And we get 0.216. So we didn't have to round off on that one. So I didn't have a chance to demonstrate rounding. And of course our answer is going to be positive because we have a negative times a negative. So if you got 0.216, you're on the right track. All right, try number 5, and when you come back, we'll do it together. All right, we're back. So 8 minus 0.34 is 7.66y. And we're going to subtract subtract 7.66y from both sides. So in my calculator, I'm going to enter 7.7 minus 7.66. and I get 0.04y. I probably could have done that in my head, but it's just so much. I've got my calculator right in front of me. It's just so much easier to do it with the calculator at this point. So now we're about to perform a calculation on both sides of the equation, so that you know what that means. We have to rewrite. Even though you don't want to rewrite, we have to rewrite to show the steps. And those cancel out. And 3.2 divided by 0.04 is 80. So we didn't have to round off on that one. So if you got 80, good job. Now if you didn't get 80, again, that's okay. Just figure out what you did wrong. So I'm going to need to put a divider line here. And let's try number 6, and when you come back, we'll do it together. All right, so I have some calculations here. I have 2.4 minus 1 is 1.4. And then 1.4 plus 0.3 is 1.7. So those are pretty easy calculations to do in our head. When you work with decimals a lot, you start to get an idea of how to do those without a calculator. So now we're going to add 4.4 to both sides. And 4.4 plus 1.7, that would be 6.1. And so now we have to rewrite because we're about to perform an operation on both sides of the equation. And we multiply both sides by 3.1. Now we're multiplying two-digit numbers here, so you can use your calculator. And I get 18.91. And I did not have to round off on that one. So if you got 18.91, good job. So as you can see, working with decimals is really the same as when you're doing other equations. It's really no different. You just have to use your calculator in some of these. So go ahead and try number 7, and when you come back, we'll do it together. All right, we're back. So combine these numbers and you get negative 7.3. And we're going to perform an operation on both sides of the equation. So we have to rewrite the equation. And we're going to subtract 0.56x from both sides of the equation. And I'm going to get my calculator. 3.888 minus 0.56. That's just one way to do it in the calculator. That's probably the easiest way to do it in the calculator. All right, now we're going to rewrite the equation again because we're about to perform another operation on both sides of the equation. And this time we're going to add 7.3 to both sides of the equation. We're going to rewrite the equation again because we're about to perform a third operation on both sides of the equation. And we need to get the calculator out. 3.7 divided by 3.328. And that's a number with a lot of digits. So we're going to round off. So we need squiggly lines. And we get 1.11177885, and it just keeps going on and on. So we're going to round off to the nearest thousandths. The green number tells us to round up. And by the way, don't forget your negative sign. I almost forgot my negative sign. It's so easy to forget your negative signs. So the final answer is going to be negative 1.112. So if you got negative 1.112, good job. Again, the green number tells us to round the blue number up 1 to 2. And then the green number and all the numbers to the right of the green number, they disappear. All right, we're going to go on to the next one. Let's do number 8 together. Number 8's a little bit different because we have this negative sign in front of the fraction. So on the right side of the equation, 3.8 minus 2.1. I've got my calculator for that. 1.7. And we're rewriting. You're going to have to write a plus sign in between those. I'm going to move that over a little bit so we have more room. So I'm going to get my calculator out. 1.7 minus 0.006 is 1.694. And it's very important to understand that this negative stays with the fraction. This negative sign goes with the fraction. This negative has nothing to do with these numbers. This negative here goes with the fraction. That's one of the most common mistakes that students make. All right, so this problem is different because the negative sign is not down here with the denominator. It's up here. But what you can do is you can just consider it to be with the denominator. So when you multiply both sides of the equation, you're going to multiply, you're going to multiply both sides by negative 0.04. And we need parentheses around both those. And sorry it's getting so cramped in here. All right. So both the 0.04 over here and the negative cancel out. So you're left with y is equal to, and we definitely need the calculator for this calculation, 1.694 times 0.04 is equal to, and it's going to be negative 0.06776. So on to number 9. Number 9 is going to be similar. So again, when you multiply both sides by negative 7.8, you have to add that negative there. So why don't you try number 9, and when you come back, we'll do it together. All right, we're back. So 3.8 plus negative 1.1 is 2.7. And we'll just rewrite this. We'll rewrite the left side of the equation. And whoops, I forgot my addition sign there. (2.7) minus 1.001. I did that on my calculator. And then we're going to rewrite that. Now, when you multiply both sides by 7.8, you have to add that negative in there, because we have to get rid of not just the 7.8, but we also have to get rid of the negative. So 1.699 times 7.8. And we get negative 13.2522. Now again, how you do this problem depends on where you consider that negative to be. If it's down here, obviously you're still going to multiply by negative 7.8. If it's up here, you could do it a different way. You could consider this, well, we won't even think about that now, but maybe in the next problem we'll try it that way. So if you got negative 13.2522, good job. All right, try number 10, and when you come back, we'll do it together. All right, we're back. So I think we can do the left side in our head. 4 plus 3 is 7, and then 2 plus 5 is 7, so that should be negative 7.7. And 1.9 plus 7.7, we'll just pretend that this is 2, and then you add it to 7.7, you get 8.7, 9.7, then you gotta subtract 0.1. So 8.7, 9.7, 9.6 should be negative 9.6. Again, if you don't feel comfortable doing that type of stuff in your head, then just use a calculator. And again, we have to get rid of the 1.8 and we have to get rid of the negative. So I'm going to do this in a slightly different way just to show you. Again, we can take this negative and we can put it down in the denominator, but what I'm going to do is I'm going to actually put it up in the numerator. And then I'm going to do one extra step. So I'm going to multiply both sides by positive 1.8. So then we get negative x. And notice the negative is still on the x. So this is not really the optimal way to do it as far as speed, but I just want to show you that there are multiple ways to think of this. And then we get 10.368 using the calculator on the left side of the equation. And don't forget to add your negative there. And then we're going to rewrite. But remember, if you have a negative next to a variable, that means it's -1 times the variable. So then we're going to divide both sides by -1. And x is equal to positive 10.368. So if you got that number, good job. The first step when solving an equation with parentheses is to get rid of those parentheses using the distributive rule. So we're going to distribute the -5.1 to both these numbers. So -5.1 times y is -5.1y, and -5.1 times 2 is, we can probably do that in our head, that's going to be -10.2. And now 3 times 1.7, that would be 5.1. And 3 times -4y is -12y. And on the right side of the equation, we can just do that. -3 minus 1 is -4. So we didn't need a calculator for that. All right. So that all looks correct. So now we have to combine like terms. -5.1y minus 12y. So 5.1 plus 12 is 17.1, so -17.1y. And then we'll combine these. So 10.2 minus 5.1, and again, you can put it into your calculator in different ways. That would just be -5.1. And now I mentioned that when you're doing equations with parentheses, I'm going to allow you to skip steps because there's going to be so many steps here. So this is the one case where I'm going to allow you to, we're not going to have to rewrite this equation before we perform an operation on both sides of the equation. So I'm just going to go ahead and add 5.1 to both sides. And again, if you don't feel comfortable doing that calculation in your head, you can use a calculator. And I'm going to divide both sides by -17.1. So again, I'm not showing this. I'm just doing the algebra in my head. So 1.1 divided by 17.1, and again, I'm not putting the negatives in my calculator because I don't. Why would I want to do that? That's just a waste of time. I know the answer is going to be negative, so I don't need to write all the numbers. So now we have another opportunity. If I know the number is negative, I should probably write a negative sign. So this is another opportunity to show you rounding. And again, you should be familiar with rounding if you took my previous course. But if you're a little rusty, that's okay. So we're just going to write a bunch of numbers there because they just go on and on and on. And now we're going to find the thousandth place. That's here. And then we're going to look to the right of that number. The green number is going to tell us whether we're going to round up or down. So if a number is 4 or lower, then we're going to round down. So the green number is lower than 4. So what that means is that the blue number is going to stay the same. And by the way, I need a squiggly equal sign here. The blue number is going to stay the same. And all the other numbers are going to disappear to the right of the decimal. And again, that's only because you would have zeros to the right of the decimal. If you have numbers to the left of the decimal, they don't disappear, they just turn to zeros. All right, so as you can see, the procedure for solving these problems is really the same that we learned for equations with parentheses when you have whole numbers. So I'm going to try to move this over a little bit. So now why don't you try number 12, and when you come back, we'll do it together. All right, we're back. 3.1 times 2 is 6.2. And 3 times 3.1 is 9.3. Again, those are some calculations that you could do in your head. 1.8 times 2.5, that's a calculator problem. We get 4.5x, and then 1.8 times 1 is obviously just 1.8. So double check all those calculations. Make sure your signs are correct. Remember, problems with signs, that's the most common mistake that students make. 4x plus 6.2x is 10.2x. So at this point, we haven't had to perform an operation on both sides of the equation. We've just been simplifying. So in the first step, we got rid of the parentheses by using the distributive rule. I'm going to move that over more. Sorry. So at this point, we would normally rewrite the equation because we want to preserve the result of our calculations. But when you have equations with parentheses, I'm going to allow you to go ahead and do the algebra in your head. So 10.2x minus 4.5x. So if I just pretend that this is a 5, 10.2 minus 5, obviously that's 5.2. But I didn't subtract 5, I subtract 4.5, so I have to take 5.2 and add 0.5 to get 5.7. So if you want to do calculations in your head, that's the type of stuff that you're going to have to get used to. So now we're going to add 9.3 to both sides, so we're going to do two steps at once. Add 9.3 to both sides, and you get, this is close to 2, so 9.3 plus 2 is 10.3 and then 11.3. But you're going to have to subtract 0.2 because this is not 2, it's 1.8, so 2 was 0.2 above 1.8, so we're going to have to subtract 0.2, so that would be 11.1. And now we're going to divide both sides by 5.7, but of course we're not going to show the step, we're just going to do it. And bust out your calculator for that, and you get 1.947368, and it just keeps going on and on and on. So I'm going to have to write squiggly signs. Squiggly equal signs. So now we're going to look to the thousandth place, and the green number is going to tell us whether or not we're going to keep the 7 or round it up to 8. So 3 is less than 4. It's less than 5, so we're going to keep the 7 and all the other numbers are going to disappear. So if you got 1.947, good job. Again, you can see that we're going a lot faster here because we're not having to rewrite every step. Now, if you wanted to rewrite every step, you could do that for these problems, but when you have equations with parentheses, I'm going to allow you to do the algebra in your head. All right, so we have two more problems with decimals. So, and then we'll go on to inequalities. So why don't you try number 13, and when you come back, we'll do it together. All right, we're back. So 1.2 times 5.3 is 6.36. And we're going to subtract 4.3 z from both sides. So 6.36 minus 4.3 is 2.06 z. And I'm going to do two steps. So I'm going to add 1.2 to both sides. And we get negative 7.4. And then without showing the operation, I'm going to go ahead and divide both sides by 2.06. And as you can see, we come up with a number with a lot of digits to the right of the decimal. So we're going to have to write the squiggly sign. So again, in case you're rusty on rounding, we look at the number in the thousands place, and then the green number to the right of it, that tells us whether or not we're going to keep the 2 or round it up to 3. So the green number is less than 5, so the blue number is going to stay the same, and all the other numbers to the right, including the green number, are just going to disappear. So if you got 3.592, good job. All right, so now you try number 14, and when you come back, we'll do it together. All right, we're back. 7.3 times 3 would be negative 21.9y. And we get 14.6 there. So those are some calculations that you can attempt in your head if you want. But again, if you're not comfortable, just use a calculator. And we're definitely going to need the calculator for this one. 12.6, and again, you can put the negatives in your calculator if you want to, but you don't have to. So we get 0.5502 and then I'm going to round off to the nearest thousandth place. So the zero's in the thousandth place, and the green number tells us that we're going to just keep that 0, that blue number, and all the other numbers become 0. But of course we can get rid of the blue number too, because that's just a 0 to the right of the decimal. You learn in my previous course that if you have zeros to the right of the decimal that are ending zeros, then you can just make them disappear. And I forgot a negative sign. Did you see how I almost forgot a negative sign there? It's so easy to forget your negative signs. Okay, so if you got negative 0.55, good job. All right, so that's solving equations with decimals. As you can see, it's just the same situation with the previous classes, except we just have decimals. So now we're going to go to graphing solutions. Now, you don't normally graph a solution when you have an equation, because the solution would just be a dot on a number line, and it's just not that interesting to graph. So you're not normally asked to graph the solution of an equation. But if you did graph the solution, this is what it would look like. So let's say that you have this equation, and we know how to solve that equation. Just get the variables on both sides, and get the normal numbers on the opposite side, and keep performing your calculations until you isolate x, and then the answer turns out to be -2. So this is the algebraic solution. That's what we've been doing so far in this this course. You learned how to find the algebraic solution. But there's also a graphical solution, and that's when you actually plot this number on a one-dimensional axis. So one-dimensional axes are just lines. If you want to plot on 2 dimensions, you need 2 lines. And of course, if you want to plot on 3 dimensions, you need 3 lines. And it's kind of hard to see 3 lines, but that's what it would look like. These dotted lines go kind of into the page. But we're not going to graph in 3 dimensions in this course. We are going to graph in 2 dimensions, but not today. Today we're just going to graph in 1 dimension, and 1 dimension is considered to be just a line. So we draw our line, and we're going, and it turns out you can graph this expression in 1 dimension, 2 dimension, or 3 dimensions, but it does have a meaning for all 3. But in this case, again, we're just going to do 1 dimension. So we draw the line. You can see we have a line here, and we have markings that tell us where the positive numbers are and the negative numbers are, and 0. And x is -2, so you just put a big old dot on -2, and that's it. It's that easy. So that's why you're not really typically asked to graph equations, because it's kind of a waste of time. It's not really teaching you much. But when you solve inequalities, which is what we're about to learn, the solution is going to be like so. It's going to be different. So we learned about inequalities in the previous course, but we didn't learn about how to solve inequalities like this one here. So you recognize this statement. Remember, Pac-Man eats the bigger number. So this is telling us that all the x values are less than 4. But again, if you read it left to right, this is read 4 is greater than or equal to x. So be sure to read left to right. This is a greater than sign, not a less than sign. So we learned about inequalities. We know the basic idea. But the difference is now we're going to solve inequalities that have variables, and we're going to graph the inequalities. So I can sit here and lecture, but it's better to just show you how to do these. Again, this is the algebraic solution, and this is the graphical solution. So let's go on. But before we go to inequalities, let's go ahead and quickly just give you some examples of graphing equations. So if you solve this equation, I'm just going to do this all in my head, you're going to end up with -1. So that is the algebraic solution. But if you graph the solution, you draw a number line, and these divisions should be fairly equal, but they don't have to be exact. You notice I was kind of sloppy there. This one is a lot smaller than that one, but you get the point. So then you just plot -1, and it goes right there, and that's it. That's the graphical solution. So we're going to write algebraic solutions, and we're going to write graphical solutions. So I need to shrink this because that's kind of oversized. All right, so now quickly I'm just going to solve this in my head. So that would be 4, z is equal to 4. So that's the algebraic solution. And you don't really need to write a 0. The fast way to do this is really just write a, well actually in this case you probably do need to write a 0. With inequalities you don't need to, but in these problems it's probably best to give some, but if I write 2's, my solution is not going to be within that frame. So I'm going to write 4's, 4, 8, and -4, -8. You can write any kind of scale you want to. So 4 would be here, and that's my graphical solution. So as you can see, the graphing is pretty easy in these problems. So if I solve, I'm going to get -4. And so that's the algebraic solution. And this would be the graphical solution. So again, we have another equation here, and I'm going to do this in my head. So that's the algebraic solution. And then the graphical solution. So I drew the number line, and the solution just goes right there. So hopefully you're getting the idea of how this works. You can see it's so easy that most teachers don't even require you to graph the solution to equations, but you are going to have to graph solutions to inequalities, which is why we're doing this. So at this point, why don't you try number 19, solve 19, and then you're going to draw a number line. And actually, you know what? We're going to have to do that one. I think we should do that one together because that's going to be a decimal. So I'm going to solve this equation, and we get 10.5. So I just want you to be aware that you can still use the number line when you have decimals. It's no big deal. So, but in this case, it's going to be kind of hard to draw it with a 0 there. So we'll just put 5. Actually, I think 8, 8.5, 9, 9.5, 10, 10.5, and so on and so forth, and we just put a dot there. So there's a lot of different ways to graph it. I just chose to graph it with these divisions. Notice I didn't put a 0 sign. All right, and if we solve number 20, we get negative 1.5. That's the algebraic solution. And try to make these divisions equal. And negative 1.5 would be about here. Because remember, 0.5 is halfway between negative 1 and negative 2. All right, so why don't you try number 21, and when you come back, we'll do it together. All right, we're back. 5z minus 2z is 3z. This is a 3-step problem. Add 5 to both sides, and you get negative 2 over here and 3z over here. Divide both sides by 3, and I'm not showing every single step here. I'm just doing the algebra in my head, because the purpose of these problems is to show you how to graph. So now we get negative 2/3, and this problem looks like I gave you a hard one already. Sorry about that. So we're going to have to graph fractions. And then the answer will be negative 2/3, so that's right here. And again, your graph might be slightly different depending on what type of divisions you chose. But the important thing to understand is that if it's a negative number, it's going to go to the right, or excuse me, to the left of the 0. And if it's a positive, it's going to go to the right of the 0. So anyway, at this point, I don't think we need to keep going with these. Well, actually, we probably do. You need to get the hang of graphing fractions. So why don't you try 22? It's going to be challenging to come up with the divisions because you're going to have an improper fraction, but try 22. When you come back, we'll do it together. All right, we're back. So the solution should be 3/7. Actually, it's not going to be an improper fraction. I thought it was going to be an improper fraction. So then you're going to have to get creative when you graph it. So let's do 1/7, 2/7, 3/7, and then negative 1/7, negative 2/7, negative 3/7. And then 3/7 would be right here. So if your graph looked somewhat like that, good job. And we need to rectangle these algebraic solutions also. Those are part of our solutions. Whoops, I forgot to rectangle that graph. And I forgot to rectangle this algebraic solution. We got to rectangle anything that's a solution. All right, try number 23, and when you come back, we'll do it together. All right, we're back. Z is equal to 3/2, so this is going to be an improper fraction. So again, this is the algebraic solution. And we'll count in halves. 1/2, 2/2, 3/2. And your solution is right there. All right, so if you got that graph, good job. Go ahead and rectangle that. So now you should have an idea of what it means to graph a solution on a number line. So sometimes you have to write fractions, sometimes you have to write decimals on the number line. So we're going to start out with just whole numbers for our number lines. But now this is an important part in your math education, important step in your math education, because we're now going to solve inequalities. You are going to use inequalities, not nearly as much as equations, but you are going to use inequalities. So right now we have something that looks like an equation, but the only difference is we have this inequality sign instead of an equal sign. So you're going to be pleased to find out that the way that we solve an inequality is exactly the same way we solve an equal sign. So what you can do right now is just pretend that that's an equal sign and just solve it the way that you normally would. So if we do that, I'm going to make you rewrite every step because we don't have parentheses in this inequality. So then we're going to subtract 4x from both sides. And we're going to get 4x minus 3. So subtracted 4x from both sides. And then we're going to add 3 to both sides. Whoops. I didn't rewrite the equation. I'm trying to go too fast here. I mean rewrite the inequality. This is not an equation. This is an inequality. We're just pretending that it's an equation. And we get 4x on the right side and 4. So you can see we're just doing it the same way we've always done it. And then I'm going to bust out my purple color, and then we divide both sides by 4. And we get x is less than 1. But if you read this left to right, it's 1 is greater than x. So don't be confused by that. That's a greater than symbol, because if you read it left to right, Pac-Man wants to eat the bigger number, so we say that 1 is greater than x. But if you want to read it right to left, it would be x is less than 1. So that is the algebraic solution to this inequality. So you can see solving inequalities is really easy. It's just the same thing that we've been doing. But now we have to graph the solution, because teachers will often ask you to graph the or to write the graphical form of an inequality. So now we're just going to write 0 for a reference. Then we have 1, 2, and -1, -2, so on and so forth. So we drew our number line. Now we're going to put a dot, but the dot is going to be an open dot, so we could put the open dot on the 1 because we have a 1 here. And the reason we're going to put an open dot is because x cannot be 1. It has to be less than 1, so we're putting an open dot. So this is where it gets a little confusing for students. X is smaller than 1 because Pac-Man wants to eat the bigger number. So 1 is bigger than all these x values. So x has to be less than 1. In fact, what this inequality is saying is that x can be anything there's actually an infinite number of solutions for this inequality. When you have an equation, you only have one solution normally in the problems that we've been doing in this course. Sometimes you have more than one, but we're not going to do those types of problems in this course. So in all the equations that we've done in this course, we have one solution, but with an inequality, we actually have infinite number of solutions. And if you haven't heard that word infinite, that just means that you cannot count the number. There's too many of them to count. So what this means is that x can be anything, but there's a limitation. The numbers have to be less than 1. So what we do is we put a bold line to show people that x can be all of these numbers to the left of 1 on the number line. So this dark line that I'm drawing here, that means our solutions can be on the number line all the way into infinity in this direction. And our solution cannot be 1, so we have an open dot here because it has to be less than 1. It can't actually be 1. So that's how you graph an inequality. So the difficult part for students is understanding, let me move that up a little bit. The difficult part for students is understanding whether or not you shade on this side of the dot or this side of the dot. That's going to be kind of confusing. So you're going to need some practice with that. All right, so on to 25. So again, as you can see, it's just the same type of problem. Just pretend that this is an equal sign and just solve it the way you normally solve it. But instead of writing the equal sign, you're going to write the inequality sign whenever you want to write an equal sign. So go ahead and try number 25. And when you get to the very end, stop and wait for me, and then we'll do the graphing part together. So solve this inequality, and when you come back, we'll do it together. All right, we're back. -6 plus 1 is -5. And so now we have to rewrite All right, then we're going to multiply, we have to rewrite. I have to get back into the mode of rewriting. Multiply both sides by 7. So z is less than -70. So that's the algebraic solution. So now, if you got z is less than -70, good job. Now again, this inequality has to be in the right direction. Pac-Man wants to eat the -70. So if you wrote it in the other direction, the other way, that's wrong. All right, so now we have to graph that solution. So you draw your number line, and we've got a 70 here, so we're going to have to move the 0 over here if we want to. We don't really have to write the 0, but actually that's the wrong direction. You have to get kind of creative when drawing these, because sometimes you get weird numbers. So I'm just going to write a -50, -60, -70. All right, so we need an open dot on the -70, and see if you can figure out, are we going to shade in to the right of the dot, or are we going to shade in to the left of the dot? That's the part that's difficult. Z is the shaded in part. That's the important thing to understand. The shaded part is going to be Z. Again, the shaded part is going to be Z. So if you shade in here, that should be Z. Or if you shade in here, that should be Z. So Z, we're told, is less than -70. So are you going to shade in here for Z, or are you going to shade in here for Z? Think about it. Z is less than -70. If you said over here, you're correct. All right. So again, it's really easy to get turned around with that. Go ahead and rectangle that. All right, so for number 26, something different is present here. So we have a sign that's a little different from what we're used to there. So this is called a less than or equal to sign, because you have the less than sign, but you also have a horizontal line below it. So that means less than or equal to. So all that means is that when you draw your graph, this dot here is going to be filled in because it can be equal to whatever our inequality says. So don't worry about the less than or equals to sign at this point. Just solve the inequality like you normally would solve an equation. And when you get to the very end, we'll graph it together. So attempt that problem, and when you come back, we'll do it together. All right, we're back. So if you got 2 is less than or equal to y, good job. So again, because this is a less than or equal to sign, we say 2 is less than or equal to y. That's the difference. So now I need to shrink this stuff so I can have enough room to graph it. So again, the graphing works exactly the same way. The only difference is that we're going to have a filled in dot. So let's draw our number line. Try to make it horizontal. And your number line doesn't have to be perfect. You notice my penmanship is not that great, but it doesn't really matter. This is not an art class. So now we go to 2 and we write a filled in dot, not an open dot. If it were an open dot, it would look like this. That's the previous problems, but in this problem we need a filled in dot because we have a less than or equal to sign. So now the problem is why are we going to shade in this region, or are we going to shade in this region? That's what's difficult for students to understand. Now the y is the shaded region. So is y greater than 2, greater than or less than 2, or is it less than or equal to 2? So remember, the Pac-Man wants to eat the bigger numbers, so that means that y must be greater than. So y is the shaded region, so the shaded region must be greater than the dot. So you shade this region over here. So we have an algebraic solution, and we have the graphical solution. All right, so why don't you try 27? Remember, you're just going to fill in that dot when you graph it. And again, the hardest part is understanding, do you shade on the right side of the dot or the left side of the dot? Remember that the variable, whatever the variable is, that's the shaded part. So if it says that the variable is greater than, that means you shade to the right of the dot over here. If the variable is less than, you shade to the left of the dot. But it gets confusing because you can write these inequalities in many different ways. I can write this inequality, I can flip it around and write it like that. That's the same inequality. So when you start to get to that point where you're flipping things around, it gets really confusing. So try 27 and go ahead and try to graph it also, and when you come back, we'll do it together. All right, we're back. 1 minus 3 is -2, and -2 minus 4 is -6. Subtract 5 from both sides. And then we're going to multiply both sides by 2. And remember, you have to put parentheses around both the 2 and the -11 on the left side of the equation, or the inequality. Again, this is not an equation, it's an inequality. 2 times -11 is -22. So if you got -22 is greater than or equal to x, that's perfect. Good job. But now we have to graph it. That's the challenging part. So let's see here. It's going to be kind of tricky to graph this. You can just put a 0 and then a 10, I mean a -10, and then a -20. I'm going to move this over a little bit. So there's one example of the divisions you can make. And then it says -22 is greater than or equal to. So we're going to go ahead and plot -22, which would be roughly here. Doesn't have to be exact. And the shaded part is x. And it says that x, Pac-Man wants to eat the bigger number, so Pac-Man wants to eat the -22. So that means x is less than -22. So the shaded part, which is x, should be less than -22. So that means you shade on this side. So again, if you shade it on the wrong side, that's not unusual to make mistakes there. So don't be frustrated. You just need practice. And we need to fill in the dot. Make sure that your dot is filled in, because it's -22 is greater than or equal to x. So if you got the right answers on those, good job. If you didn't, just figure out what you did wrong. All right, so in the next problem, something different is going to happen. So let's go ahead and do this problem, and then I'll show you what exactly is going to happen. So on this step, we're going to divide both sides of the inequality by -9. But an important point that a lot of students forget when they do these problems, and you haven't learned this yet, so you can't forget it, but when you multiply or divide both sides of an inequality by a negative, then you have to flip the inequality. So we're going to divide both sides by a -9. And so we're going to have to take that inequality, and right when we divide, on this step we're dividing by -9. So this statement is no longer true unless we change that inequality sign in between to, unless we flip it to make it a greater than sign. So here it's a less than, I flipped it to a greater than sign. So you have to do that when you multiply or divide both sides by a negative. In this case, we divided both sides by a -9. Now you don't have to do that if you add or subtract a negative from both sides. It's only when you multiply or divide both sides of an inequality by a negative. So again, we're dividing both sides by -9, so we have to flip that inequality. And it's very important to understand that you have to flip it in this expression right when you divide. So we end up with y is greater than, and 27 divided by -9 is -3. So that's the algebraic solution. So again, that's the only difference for this problem, is that we're dividing by a negative number, so you have to flip the inequality. So we have, let's see, put -4, -3. And we need an open dot, and y is greater than, so y is the shaded part, so the shaded part is greater than, because Pac-Man wants to eat the greater than, the greater number. So y is greater, the y is the shaded number, so the shaded part is going to be to the right of the dot. All right, so on number 29, you're going to have to flip the inequality again, because you're going to multiply both sides by -3. So, and remember, you have to flip that inequality right when you multiply on that very step. So go ahead and try number 29, and when you come back, we'll do it together. All right, we're back. 1 minus 2 is -1. So now we're going to multiply both sides by -3, and be sure to put parentheses around both these numbers. So because we're multiplying both sides, I have to erase that inequality, and I have to write a less than or equal to sign. I have to flip it. So that is the algebraic solution to that problem. So if you got 18 is less than or equal to z, good job. So now let's graph it. And again, graphs will vary depending on what you choose to do. And let's mark the 18, and it's going to be a closed circle. The previous problem was an open circle, but this is going to be a closed circle because we have less than or equal to. So it's going to be approximately there. And again, it doesn't have to be exact. And z is the shaded part, so z, Pac-Man wants to eat z, so that means z is greater than 18. So the shaded part is greater than 18. Z is the shaded part, it's greater than 18. So you shade in this part here. And I forgot to rectangle that answer over here. We've got to rectangle these. It's kind of hard to rectangle such a big solution. So if you got that algebraic solution in that graph, good job. All right, so try number 30, and when you come back, we'll do it together. All right, we're back. But I know I'm going to have to flip my inequality sign, because I'm going to divide both sides by a -4. So if you got that algebraic solution, good job. So now we're going to graph it. So we graph 3/4 with an open dot. And x is, Pac-Man wants to eat -3/4, so that means x is less than -3/4. So the shaded region is x. X is less than -3/4, so we shade this region over here. My graph isn't really written that great. All right, so if you got that answer, good job. On to 31. Go ahead and attempt 31, and when you come back, we'll do it together. All right, we're back. So I know that I'm going to have to flip the inequality sign because I'm going to divide by a negative. Whenever you multiply or divide by a negative, you have to flip that inequality sign. So if you got y is greater than or equal to 3/2, good job. And if you count in terms of halves, it makes it easier to graph. Whoops. I keep drawing my graph in a way that's not exactly optimal. So we have a colored in circle, and y is greater than or equal to, so we color this part in. Y is the shaded part, so Pac-Man wants to eat y. So y is greater than, so y is the shaded part, so it should be to the right. All right, so if you got that solution, good job, and try to rectangle your graphs because that's part of your solution. I forgot to rectangle my graph over here. All right, so on to number 32. Go ahead and try 32, and when you come back, we'll do it together. All right, we're back. And this is a problem where you don't have to flip the inequality sign because we're not dividing by a negative, we're just dividing by +2. So if you got z is less than 0, good job. Now let's plot that. And it's an open circle. And the shaded part is z, and z is less than 0, so I shade in this part here. So if you got that graph and that algebraic solution, good job. Again, you have your algebraic solution and your graphical solution. So go ahead and try 33, and when you come back, we'll do it together. All right, we're back. So now we have to divide both sides by a negative. So we're going to have to go ahead and flip that inequality sign. And I forgot to put my equal to there. And we get 7 is less than or equal to x. So if you got that algebraic solution, good job. So now let's graph it. going to graph in intervals of 5. And 7 would be right around here, and it's going to be a closed dot because 7 is less than or equal to. So Pac-Man wants to eat the x, and that means that x is greater than 7. So x is the shaded part. So if x is greater than or equal to 7 and x is the shaded part, that means the shaded part is to the right. So over here. Now if you're having trouble figuring out if the shaded part is over here or over here, don't worry, that's normal to make mistakes with that. You'll get it over time as we do more and more of these problems. Alright, so if you got those solutions, good job. Try number 34, and when you come back, we'll do it together. Alright, we're back. So now we're going to multiply both sides, so I have to flip that inequality, and I have to make it a less than sign, because we're multiplying both sides by a negative, in this case negative 5. So y is less than negative 10. Have you got that solution? Good job. So now we're going to make our number line. So y is less than negative 10. So negative 10, we need an open dot. And again, the Pac-Man wants to eat negative 10, which means that y must be less than negative 10, or y must be less than negative 10. So y is the shaded part. So we shade in this part over here. So if you got that graphical solution and that algebraic solution, good job. Try number 35, and when you come back, we'll do it together. All right, we're back. So now we are multiplying both sides by 4. We're not multiplying by a negative, so we don't have to flip the inequality sign. But you do have to put both these in parentheses, both these numbers in parentheses. So negative 32 is less than or equal to x. So if you got that answer, good job. That's your algebraic solution. So I'm going to do intervals of 10. And negative 32 is somewhere around here, and we need a filled in dot. I'm making my dots extra big so you can see them. So Pac-Man wants to eat the bigger number, so x is bigger. X is greater than or equal to negative 32, so that means we shade in the right side of the number line. So if you got that graphical solution and algebraic solution, good job. All right, on to number 36. Go and attempt 36, and when you come back, we'll do it together. All right, we're back. And now we're going to divide both sides by a negative. So that means I have to erase this greater than sign and put a less than sign, less than or equal to sign. So z is less than or equal to negative 4/5. So if you got that solution, good job. Now graphing it is going to be a little challenging because we have a fraction. So you can count in fifths. So z is, Pac-Man wants to eat the bigger number. That means z is less than. Z is the shaded part. So graph your dot there. Fill it in because it's less than or equal to. And z is less than, so it's going to be this part over here. So if you got that graphical solution and algebraic solution, good job. Try number 37, and when you come back, we'll do it together. All right, we're back. 15y minus 12y is 3y. And I'm going to have to flip that inequality sign, make it a less than sign, because I'm about to divide both sides by a negative. And y is less than 6/7. So if you got y is less than 6/7, good job. Now let's graph it. This is going to be a little difficult to graph, so I'm not going to write a real detailed graph. So 6/7 is going to be somewhere around here. It's going to be an open dot, and Pac-Man wants to eat the 6/7, which means that y is less than. So the shaded part is y. So shade this part in here, and if you got that graph, good job. Try number 38, and when you come back, we'll do it together. All right, we're back. And in this case, we don't have to flip the inequality because we're not multiplying or dividing by a negative. But we do have to reduce this fraction. Divide both sides by 3 and you get 7 over 2. So if you got x is less than 7/2, good job. So let's see, this would be again, it takes some creativity to graph these. So let's make this 2/2, 4/2, 6 halves and 7 halves. Actually, that should be 8 halves, I'm sorry. So now, put an open dot, and X is this region over here, shade in that region. So if you got that solution, good job. Now I want you to be aware that if you want to, what you can do is just draw a number line, make any mark there, and write it as 7 halves, and then color in the other side. If you want to do that, then of course you need an open dot. If you want to do that, that's fine. I don't really need you to draw a detailed graph. You just need to figure out what side to shade in. As long as you know which side to shade in, then you're fine. All right, number 39. Something different is going to happen here. Let's see what's going to happen. It's probably just because we have a negative on the fraction over there. So it's important to understand that negative goes with the fraction. That's one of the primary, that's a common source of error for students. And now, I mentioned in previous classes that this negative, you can consider it to be up here or down here or here. It really doesn't matter. The easiest way to do this is to multiply both sides by -4, so we don't have to do an extra step. So we're going to multiply both sides by -4, and before I forget, I need to flip that inequality sign, because we're multiplying both sides by a negative. And if you got, well, we didn't do this one, you didn't do this one on your own, so z is less than 32. So 32 is here, and we need an open dot. And z is less than, so we shade in this region here. All right, why don't you try number 40? And remember, this negative sign, you can just consider that to be negative down in the denominator, however you want to consider that, but you got to multiply both sides by -7. So try 40, and when you come back, we'll do it together. All right, we're back. So I'm going to multiply both sides by -7. Be sure to put parentheses around both these numbers. And I have to remember to flip that inequality sign so it becomes a greater than or equal to sign. So if you got 42 is greater than or equal to x, good job. Let's graph it. .42 is roughly here. Seems like we're getting a lot of numbers with 2's on them. And we shade that in because it's x is less than or equal to. And you're going to shade this region here. And again, your graph doesn't have to be perfect. This is not an art class. All right, so if you got those answers, good job. Try 41, and when you're done, we'll do it together. All right, we're back. And we're multiplying both sides by a positive, so we don't have to flip the inequality. That's good. So if you got y is less than 16, good job. So I'm just going to use intervals of 10. 16 would be roughly here. And we need an open dot, and it's less than, so we're going to shade in to the left. Remember, y is the shaded part. Y is less than 16, so the shaded part has to be less than 16. So if you got those answers, good job. All right, number 42, go ahead and try that one. And when you come back, we'll do it together. All right, we're back. Now in this case, we are going to have to flip the inequality because we're going to divide both sides by -12. So 1/12 is less than z. So if you got that algebraic solution, good job. So we're kind of pressed for time here, so I'm just going to graph this quickly. (1/12) would be about here, very close to 0. And z, Pac-Man wants to eat the bigger numbers, so z is greater than. So you're going to shade this region over here. So if you got that graph, good job. All right, try number 43, and when we're done, we'll do it together. All right, we're back. And we do not have to flip the inequality sign because we're not multiplying or dividing by a negative. So if you got y is greater than or equal to -4, good job. So it's going to be a closed dot. And shade to the right. So if you shaded to the right, good job. Again, it can be kind of confusing figuring out which side to shade. Y is the shaded part. Y is greater than because Pac-Man wants to eat him. So y is the shaded part. Greater than goes to the right. It's always to the right when it's greater than. When y is greater than, when the variable is greater than. But the variable can be on the other side, so that's what makes it confusing. All right. On to number 44. Looks like we have 2 more problems here. And then we'll be done for the day. So this was kind of a long class. So I'm proud of you if you got this far. So now we have parentheses. So in case you forgot, the first step with parentheses is to get rid of the parentheses. So we're going to go ahead and do that using the distributive rule. We'll do this one together, and then you can try the other one on your own. So we got rid of the parentheses. And thankfully we don't have to flip the inequality sign because we're not multiplying or dividing by a negative. So we get x is less than or equal to 1. Let me just double check that. Yep, that looks correct. And let's graph it. So you can try graphing this if you want. X is less than or equal to 1, so we put a colored in dot on 1. And then shade in this region. All right, number 45. So again, the first step is to get rid of the parentheses, so go ahead and try number 45, and when you come back, we'll do it together. All right, we're back. Positive 2 times negative 4x is negative 8x. 2 times 3 is 6. Negative 1 times x is negative x. Negative 1 times positive 1 is negative 1. Remember, when you have a negative here, you just consider that to be a negative 1, and you multiply. So it just changes the sign inside here. And looks like we got lucky again. We don't have to flip the inequality sign. But remember, when you divide or multiply by a negative, you have to flip that inequality sign immediately. So if you got 2/7 is greater than x, good job. Let's graph it. So I'm going to graph in sevenths. X is less than 2/7 because Pac-Man wants to eat the bigger number, so that means x is less than. So mark your 2/7 with an open dot, and less than is over here. When x is less than, it's over here. X is the shaded part, x is less than, so we got to shade in less than the dot. All right, so that was the, we'll go ahead and rectangle that. That was the class today. That was kind of a long class. We learned quite a bit. And we simultaneously reviewed all of the stuff that we learned in previous classes. Not all the stuff, but most of it. Here's all the work that we've done today. If you'd like to take screenshots of these pages to use for your homework or to help you study for tests, go ahead and do that now. Now let's look at the homework. Here's the homework. So get a screenshot of that. Be sure to do it completely and correctly. And notice that I have red lines here. That just makes it easier for you to see. And do that homework completely and correctly. And I'll look forward to seeing you in the next class.